Hello, everyone. My name is Pedro Pessoa, and I work as an SRE for StackPath. And today, I'm going to be talking to you about the world's most edgy MongoDB cluster. And that's nothing more than a MongoDB cluster that spans the world and how we can set one up very quickly and easily. So what I'm going to be going through the motivation for this. Why do we want to do it? What do we want to get out of it? So the requirements, the technology that I'm going to use to spin this up, how it is deployed and actually deploying it, and also the code to automate all of that deployment. So first, the motivation. What do we want to do and why? So we want to feed all of the world's data into MongoDB. So you see all those bright spots, that's potentially data producers, and we want to feed all of that data into a MongoDB cluster. Is that an exaggeration? It probably is, but it is a potential use case. So we might have data producers all over the world and producing terabytes of data, and we may want to feed that data to a cluster so that it can be queried, can be stored, and can be used later on. And apparently this can be as simple as a matter of scaling. So we scale the producers and we scale the cluster that is taking in all of that data. But obviously, what do we have to do to make this work? Can we be smart about it? Which are the characteristics that we can identify to make this feasible? So let's make some assumptions. Let's assume that the data is produced locally, so we can most likely ingest it locally, and with that local intake, we don't have to require any significant inter-region traffic or a huge centralized intake point. So if we distribute the intake, we can probably make this scale. About querying, when we produce data locally, it's highly likely that we also want to query it locally, and we don't need, in most cases, to have queries spanning more than one location. Obviously, we want to keep this option open. So if we want to query the entire data set, we should be able to, and let's keep that option open. So how do we go about to do this? How do we eat an elephant? So that's one bite at a time. So one of those little bright spots at a time. And what kind of technology can we use to do this? MongoDB Charging. That's some functionality of MongoDB that has been around ever since I can remember. And it's a well-known pattern to scale the MongoDB database to take in huge amounts of data. It allows you to grow the database horizontally by sharding that data to multiple sharded nodes. I'm not going into detail about sharding, but just a couple of key points that will be important for this presentation. So the application that is feeding the data does not know about the sharded cluster. It knows about one particular Mongo instance, which is the MongoOS, the router, and it reads and writes using that MongoOS, that router. And it's that MongoOS that knows about where the data is and where it is going and how to query that data. One other important part of sharding is that the data nodes, the sharded nodes, can take advantage of data locality and keep the data in their own location. So we are going to use that as a characteristic for our setup here, because each of the sharded nodes is going to be allocated a zone, so one of those bright spots, and the data will be tagged and will be kept in that zone, in that sharded nodes that will be assigned to a zone. There's one word of caution regarding sharding, is that it's complex and requires some planning and maintenance work. It's mostly true. There's now, since MongoDB 4.2, you can even change the sharding key, which is something I'm going to mention further on. But nevertheless, it's still somehow complicated to set up a sharded cluster and manage it. What I'm going to try and show you is the deployment and running characteristics of this particular shard to do this particular job. So as I mentioned, we are going to deploy the nodes as closer to the data producers as possible. We will need to take some care into selecting a sharding key. Basically, the sharding key is what is going to be what is used by the MongoDB cluster to split the data and store it according to what we desire. In this case, our major and primary goal is to have the data local to the producers. So part of the sharding key will contain the location of the data. And the other part is that we will define zones in the shard. So we are going to define one zone, for example, for Miami or for Madrid, and the data that is produced from those locations will remain in that zone, in that shard that is deployed to that particular zone. The important part of the deployment is where we are going to deploy. So as I mentioned, we want to deploy closer near the users and as many locations as possible. So I'm going to use the Stack Path Edge computing platform as a deployment target for this. So we are going to have 22 locations around the world. I already gave a couple of examples. You see there Madrid, Miami, but there are others. So let's deploy to all those 22 locations. And very importantly, we want all of these locations when we deploy to be in the same network, so in a seamlessly the same network. So we don't want to set up any VPC peering between these locations. We want all of the nodes to be able to reach each other seamlessly and as transparent as possible. The other requirement is that when we deploy our application to all these locations in the world, we don't want any specific knowledge in our application about locations. So when we deploy that application to Madrid, we want it to automatically send the data into the Madrid MongoOS to the router. But if we deploy the same application to Miami, we want it to do the same to the Miami MongoOS. And that is possible because the StackPath Edge computing offers you an anycast IP address, and we are going to use that for the MongoOS. So the MongoOS, the router, will have an anycast IP address, and you can use that address to reach the MongoOS the same way as if you were in Madrid or if you were in Miami, for example. And obviously, we want to do all of this with containers so that we don't have to manage servers ourselves. So, about deploying. These are the containers that we will be using. So the MongoDB official Docker image. So that's the first container. And we will be able to use this container to all the MongoDB servers, the data nodes themselves, the MongoOS, the configuration servers, which is also part of the sharding cluster that I didn't mention, but that's where the information about where the data is stored. And we are going to use the MongoDB official container for all of that. We also want to have visibility into our cluster in the Cloud Manager, in the MongoDB Cloud Manager. So we are going to use that second container for the MongoDB agent, and that will do the job of reporting all the cluster information to the MongoDB Cloud Manager. And last, we have a little another container that is just useful for us to look at the data. It's just a UI interface to the data that is in MongoDB. So that's just to make data visualization easier. We are going to use the Terraform Stack Path Provider to automate all of this deployment. And in short, we will have 22 MongoOSs, so 22 routers, one per location or one per data producer. We are going to have 3 configuration servers. That's to build the configuration, the sharding configuration cluster. So that's at least 3 because that's a recommended minimum. And we are going to deploy one in the Americas, one in Asia, and one in Europe. And lastly, we'll have our data nodes. So again, 3 per location. That's the recommended size for a replicated cluster. And that's what we're going to have per sharded location. So 3 times 22, that's 66. Now the code for this. I'm going to. This is on GitHub, so you can take a look at all of the code. I'm just focusing on a couple of lines and a couple of highlights here. So let's start with the data nodes. So we want to deploy a replica set per location, and that will be each shard will be deployed like this. Here we see the locations being invoked, so that this will iterate through all the locations and deploy it there. The command that we will be passing to the MongoDB container. So this is what launches a MongoDB data node and giving it the replica set parameter with the remaining nodes of the location. So once this replica set comes up in a specific location, it will know about the other two nodes, and we will be able to configure the replica set per location there. So as I mentioned before, we are going to have 3 nodes per location, per city, let's say, and we are getting the city codes from our location list. Our location list is here, so the 22 locations that I mentioned will be used to iterate on this module, and we'll be able to use the Terraform module that I showed before on the previous 2 slides to instantiate all of the 66 data nodes across 22 locations. So that covers the data nodes of the sharding cluster, so the shards themselves. Now, for the configuration servers, you can see that we are going to use the same image. The command is obviously different, so we are going to pass it the configuration server options, and this will launch a configuration server. We want those configuration servers to be into 3 different continents, and we can see here the locations where we want to launch them. So Dallas, Frankfurt, and Hong Kong. So we want one of the configuration server replica set in each continent, so that the data is as safe as possible. By the way, the configuration server data is one of the most important pieces of data on the sharded cluster, because this is what gets used to see to find the data where it is actually stored. And here is the MongoOS, the router nodes, and the anycast IP address that I mentioned before. So we are going to use, again, the same MongoDB container image, but with different, again, a different command. So this command is going to launch the MongoOS and point it at the configuration servers that we have launched before. So you see them referenced here. So we are launching the MongoOS, referencing the previously launched configuration servers. And they will be able to connect to the configuration servers and know where the data is stored by querying them. The location is 1 per city, or per the locations that we've seen before. And that is to be local to the data producers also. And as I showed before, as I mentioned before, we are also launching a little UI tool to visualize the data. You can use this for easy querying through a web interface. The MongoDB agent for the cloud manager, so that when we launch all of this, it will be easily visible on the MongoDB cloud manager. There's one important detail here, is that you can pass secret values using this API, and the Terraform provider will pick it up and provision it for you, but it will never be shown on any UI of the stack path edge compute or anything like that. So it will be a secret. And here's the image that we are going to use, the container image. So running all of this, once we launch all of that, we can see it in the MongoDB Cloud Manager. So we see some nodes of the shards of each shard replica set. Here you can see the Frankfurt shard. Here it is. You can see here the London shard, the Madrid shard, the routers per location, the router in Madrid, the router in London. Here are the 3 configuration servers that we've launched. And once you start inserting data into this shard, you can see it reported back in the MongoDB Cloud Manager. Because we are using zones to tag that data, the data will remain in that location. And because we are using the MongoDB router, if you send a query that contains part of the sharding key of that location, that query will never leave that location. But if you decide to query more global data, the MongoS, the router, will be able to send that query to all the other shards and get the data back for you and show it to you with a single interface to the data. So in a few minutes, and this takes less than a minute to launch after all is provisioned, on the code you will also find some boiler templates to do the sharding configuration. That is generated from Terraform also, so you can also take a look into that. This allows us in just a few minutes to launch all of this and making it available for data intake and querying in a couple of minutes. So a quick and simple, manageable cluster. So that's the most edgy MongoDB cluster. Thank you.